Hi, let's solve today's daily challenge, that is majority element. So in this question, we are given an array nums of size n and we need to return the majority element. Now let's see what a majority element means. Majority element is the element that appears more than n by 2 times. Okay, and this is the seal, right? And you may assume that the majority element always exists in the array. Okay. Now you are being told you have to return an element which appears more than n by 2 times inside of the array given. Right, so the question is pretty straightforward. Now let us go ahead and try to see how we can solve it. Right, so one solution is definitely there, that you try and loop through two loops, right? So let's say you choose two and then you loop for the rest of the element and compare those elements. If they are equal to 2, right, you count them, and let's say you take a max variable and you keep, after each and every iteration, you'll keep inside of the maximum element that you could get. Okay, so it would be a simple looping from I to 0 to n. Okay, and inside of it you will have j 0 to n. So for every I you choose, you'll calculate the count of each and every element, and inside of the max you will store, and you will check if the max value is more than n by 2. If it is more than n by 2, then I can return which element that is, right? Okay, so we understood one solution, but this would be having a time complexity is big O of n square, right? Then you'll say, what if we sort it? What if we sort it? Valid solution. We can sort it in n log n, right? Time complexity is also reduced. We sort it and then we simply iterate in this array and keep checking for every element. So like if I sort it, I'll get this 1 1 1 2 2 2 2 2, right? And then what I'll do, I will check for, I will start with 1, right? And I will keep incrementing the counter as soon as I keep getting 1, and after that as I get 2, so I'll say now the counter should be stopped and this should be saved somewhere. So let's inside the max variable, we'll store it. Then we'll move on to 2. We'll calculate the occurrences of 2, and then after 2 is done, we will store it inside of our max variable. And this way, our max variable will be able to return us the element that appears n by 2 times, right? So that is the majority element basically. So here this is also a valid solution, but the time complexity is n log n. Okay, can we do better? Yes, we can do better. We can use a map. We can use a map, right? We can hash all the values. So we'll say make a map, and for 1 you'll store how many times it appears. It appears 3 times. For 2 you will store, so 2 appears 4 times. So you'll save these values, and after that you will simply iterate in this map and you will check for all these values, right? So you'll check for which value appears more than n by 2 times. So here if you see, the array length is 7, so the value should be appearing more than 3 times, right? More than 3 times, and that is 2 in this case, correct? So that will be my answer. So this way also you can solve. Now here the time complexity although is reduce to big O of n because we are only doing 2 iterations, right? But the space complexity is being consumed. That is whatever we can assume that is also going to be big O of n in the worst case. Now, can we do much better than that? So if I want to do better than that, then I obviously know, see, I cannot reduce the time complexity further. Reason being, I have to iterate in the array to check for all elements, right? And space complexity, can we decrease this? Yes. So there is a algorithm called Moore's voting algorithm. Okay, using that we can achieve a space complexity is big of 1. Okay, that is constant space and linear time complexity. We can solve this question. Now let's look at it, the Moore's voting algorithm. So this algorithm says, given an array, okay, let's take the array nums is equal to Right, let's say we are given this array. So Mure says you pick a candidate. Okay, you will do what? You will pick a candidate. And you will say, I am assuming that this is my majority element. So what is a candidate? Candidate says, I am the majority element, right? So you will initialize this to nums of 0. Okay. Now, you'll start iterating in nums from I is equal to 1 to n. Okay. Now what you will do is you will check if the current element that you are at, if it is equal to candidate, right? Here you will also take a count variable, right? Initially it will be 1 because you are considering this as your candidate. So you assumed that this is your candidate, right? And you will check how many times the candidate appears, right? Okay, so you will iterate here and you will check if candidate, the chosen candidate is equal nums of your I, right? Now what? Now, if it is, you will increase the count. Okay. But now what if it is not? Then you would decrement the count, right? Else, decrement the count. Okay. Now, obviously, count should not be less than 0, right? Now, as soon as your count hits 0, what should you do? You should pick another candidate because, see, the intuition behind this algorithm is that the candidate that we are assuming, right? If it gets consumed throughout the array, then that means it was not a right value and we would pick another candidate. Intuition being that the element has to appear more than n by 2 times. So that means all the other values, right, which are not candidate will definitely be consumed, and throughout the whole iteration, the candidate you will be left with would actually be the majority element. Let us try the algorithm out here. So I'm saying as soon as my CNT becomes 0, okay, this will be above this block, right? Let's say from previous iteration CNT became 0. So what I'll say pick up the new candidate, and that would be my current element. And we will also put CNT is equal to 1. All right, now let us try to dry run this algorithm, right, and see why it works. Right, so this is the array given to us. So I pick this as my candidate. Okay, this is my candidate and count is currently 1. Then I move to this. So what would happen? Candidate will remain 1 and CNT will become 2. Okay, great. Then we will come to 2. Now I can see count is not 0. So I'll not do anything with the candidate. I'll simply reduce the counter to 1. Okay, then I'll come to this 2. Then I'll decrease the counter again. And make it 0. Okay, now I come to 1 and now I can see my counter was 0. So I'll pick this, right? I'll pick this up. So I'll say candidate will become the current element. So again, candidate has become 1. All right, and CNT is also 1. Then we will come at this 2, right? This is 2. So now count will decrease to 0 again. Okay, then I'll move to this and I'll see, okay, count is already 0. So I have to pick this as my candidate. I'll pick this as my candidate. And after this, we have no more elements. So I am left with candidate. Candidate is equal to this 2. Okay. And in this count, we have 1. All right. Okay, so we said we have gotten a potential candidate element. Now we are not done here yet. Okay, what we have to do is we have to check if this is actually the candidate, because the majority element definition is it should appear more than n by 2 times. Now what can happen in the array is sometimes maybe the element is not present n by 2 times, but it is present more than the times other elements are present. So in that case also I would get that element as a candidate. But I have to check whether it is present more than n by 2 times. So I'll simply iterate in the array again, and with another counter value, I will check for, I will simply check how many candidate elements are present inside of the nums array. So in this case, I would get 4, right, after iteration. Now I can clearly see that 4 is more than n by 2. That means the candidate that I picked from the array is my majority element, and I can return this answer. So now I hope you've understood what Moore's voting algorithm is. What we are trying to do is, we are trying to assume a candidate. Okay, we said take the first element as the candidate. Why we are able to blindly do it? Because the definition of majority element, it must be appearing n by 2 times, right? So that means whichever element I pick, let's say I pick this, it will definitely be consumed because it is not present n by 2 times, right? So for all the elements which are not majority elements, right, I'll pick them as candidate, but still in the end I would be getting candidate as my majority element only, correct? Because that majority element cannot be consumed because it is present more than n by 2 times inside of the array, right? So this is why this algorithm works. So there are 2 steps in this algorithm. First, we pick the candidate, right? We assume the candidate and we do this iteration, right, as I discussed here. After this iteration, we have a candidate element with us, and after that I have to simply check if this is present more than n by 2 times, because only then I can say this is my majority element, right? So candidate is, it is a potential element that can be my majority element, right? But I can only be sure that this is the majority element is after I calculate how many times it is present inside of the array. If it is present more than n by 2 times, then definitely it's my majority element. Otherwise, it is not. Even though it is a potential candidate, but because it is not present more than n by 2 times, it is not an answer. Okay, so I hope you understood it. So you can see that we would be iterating once here and twice to calculate the occurrence of the candidate inside of the array. So there would be 2 iterations. So time complexity will be big O of n, and space complexity would be constant because we are not using any extra space. Okay, now I hope you understood it. Now let's quickly go and code it out. So what we have to do, we have to pick candidate. So candidate will be the very first element of the array, and we have to also take a count. Okay, after this we have to iterate in the array from the first element. Do I plus plus, and then what I will do, I have to first check if count is 0. If it is 0, then I have to pick the current element as my candidate. Okay, so I'll say nums of I will become my candidate, int will be 1 now, right? Else if we have to check candidate is equal nums of I, right? Whatever candidate I assumed, I have to check if it is equal nums of I. Then I have to increment my counter, else I have to decrement the counter. Okay, now we are done with this. After this loop, I would be getting a potential majority element, and I have to check whether this element is majority element or not. So for that, we will iterate again. So I'll take another counter 2 here, and I'll initialize it to 0. And I'll iterate in the nums array again. And we'll simply compare equal nums of I. Then we would increment this counter. After this, I have to simply check if this counter 2 is greater than n by 2, right? If it is, then I will return my candidate element. Otherwise, I have to return -1. But here it is not mentioned, but I have just told you that if, let's say, we don't get this as majority element, that means there is no majority element that appears, more than n by 2 times, correct? So now let us, okay, I have written if here. So it is returned. Let's quickly run it. Okay, we have not declared in num dot size. Okay. So it's accepted. So this is basically how we have to solve this question.